Hi guys, in this video we're talking about basic collision detection in Unity. And collisions are very important in almost any game because you want to be able to have objects that interact with each other. And in order to do so, they need to know if they're colliding. So what we're going to do is, first of all, use the same sort of template that we had before. And continuing from the last tutorial, we have this sprite, which has the sprite renderer and custom sprite script. And if we start the game, we can move around. Okay, I gotta turn off the rotation thing. So if you open this custom script thing, you'll get here. I'm going to comment this out because we don't want any rotations. And now we are going to create yet another sprite so that we can check how collision works. 2D object, so it's right click in this hierarchy thing, 2D object, sprite, and select the asset. There's a circular button that you can probably see in the video all the way to the right of this property. Click on the square thing, and it should look like this. I'm going to change color to red to signify that it's an enemy, perhaps. Rename this, which is F2, and select enemy, or rather type enemy. And then we're going to attach a component. We're going to attach a collider. Box collider 2D. You can see that the 3D option doesn't have the suffix called 2D. Then for everything, you pretty much have a 2D version of it. Since we're making a 2D game, we want a 2D collider. Collider is like a bounding box or a hitbox around your game object. And that's the thing that collides. It tells you the physical bounds of a game object, as it were. Or logical bounds, I should say, which are different from visual bounds. Visual bounds are these, like what you can see. But in terms of the collision detection thing, you can see that the bounding blocks currently matches the visual bounds, but I can change that, for example, if I wanted to. So that's an important sort of part to how physics and everything else works, really. That there isn't a direct correlation between logical and visual bounds. So we've added the collider to our enemy. Let's add another collider to our my sprite, apparently is the name of that. And then we're going to also add a rigid body. The way collisions work in Unity, it seems that you need to have at least one game object that has a rigid body attached to it. Otherwise, collisions don't work. So we're going to add a rigid body 2D. We're going to change the body type to... Actually, let's run this first so that you can see what dynamic looks like. It just dropped. Because dynamic rigid bodies are driven by the physics engine. And because the gravity scale is set to 1, we have gravity attached to that game object. And in this case, we don't want that, so we're going to change to kinematic. You could change it to static, in which case it just becomes sort of a solid, not moving rigid body. This is very similar if you've done FXGL. And that's because both FXGL and Unity use Blocks2D as their 2D physics engine. So the terms are very similar. We're going to turn on this tick box, which is useful kinematic contacts, so that we're not doing sort of physics simulations, but we're moving the game object ourselves by just modifying a transform component. And then we want to turn on is trigger for my sprite so that it gets notified when it gets triggered by something. Now we can go to Visual Studio to modify our custom sprite script. We'll need to override on trigger enter 2D. And that is the thing that will be called when the trigger gets triggered. Let's just add a debug message saying trigger happened, so we know it happened. Okay, so when we collide with it, we can see the trigger messages pop up every time I begin collision with this enemy sprite. And then if we deselect is trigger, we're not going to get any of the messages. So make sure this thing is selected. Right, so we're now able to detect collisions between two game objects. What can we do? Well, for starters, how about we add new sprites? We're going to call them coins. And every time we collide with a coin, we're going to collect it, which kind of increases score by 1, and then removes the coin from the game world. Let's create a 2D object called sprite. I'm not going to be needing enemy anymore. This thing is going to be coin 1. And select the circular button, click square, change the color to yellow, I guess, because it's a coin. Bright yellow, green-ish. Add a box collider. And I think we're good to go. How about we just resize this so it's smaller? And the resize would be basically scale. So we're going to scale this uniformly so it looks like a tiny coin. And when we collide with it, there is a message that is saying triggered. Let's just copy and paste that multiple times. So another coin over here, right here, there. So we have 4 coins. And let's go back to our script. Let's add a private variable called score, which is set to 0 initially. When we trigger a collision, currently we don't really care about the type with which we're colliding, and that information can be obtained from here. We will get into that collision collider object sometime in the future when we add tags and things like that. Currently we only have 2 game objects, or rather 2 types of game objects. We have the player sprite, as it were, and then we have coins. So we're just going to increase score by 1, and we are going to destroy a coin. So destroy is basically like saying remove this game object from the game world, and then you pass the object to remove, which can be obtained from the collision, which very conveniently tells you the object with which you collided. So every time I collect, it disappears from the game world, and I assume my score goes up. You may want to print score to the thing. Score is 1, score is 2, 3, and 4. Nice. So in this video, we created a bunch of game objects. We added a collider box around them, which gives us a rectangular bounding box, which can be used for collisions or other triggers, I suppose. We then used the onTriggerEnter callback to get notified of any collisions between our sprite and other things like coin objects. And then based on that, we modified some internal state, which is basically just an int. We destroyed the coin and then we printed something to the console. On that note, thanks for watching, and we'll continue some other time.